Hello friends, today we are going to discuss the topic of cooling of power transformer. In this topic, the main table contain are general introduction of cooling, methods of cooling and application of power transformer. Various losses are taking place in the transformer are ordered to nearly 1% of the full load KV rating. These losses get converted into heat. This heat increases the temperature of the winding, core, oil as well as tank of the transformer. The heat is dissipated from the transformer tank and radiated into the atmosphere. Various cooling techniques are used to maintain the temperature rise of various parts within the permissible limit. The transformer oil is used for a cooling as well as insulation purpose. Cooling is provided by circulation of coil. The smaller transformers do not use the oil, so for them the cooling is provided by natural or thermal conversion. This is called air cooling. For a large transformer, natural air cooling is not sufficient. Hence, the forced air cooling is used where the fans are used to take away the heat. For the still large transformer, the cooling oil is circulated in the transformer parts by means of the oil pump. The number of different combinations of the oil cooling, natural cooling, forced air oil, natural air cooling are available in market. And now we use the size of the transformer and demand of the particular application. They are divided in various cooling methods. Generally, the cooling system are divided in two parts. They are first one is air type cooling or second one is oil cooling. In the air cooling, there are two parts. First one is air natural cooling and second is air blast cooling or air forced cooling. In the oil type cooling system, they are divided in various parts. First one is oil natural cooling, second one is oil natural air force cooling, next is oil natural water force cooling, next is oil forced air natural, next is oil forced air force cooling system, and then oil force and water force cooling system. Now we discuss all parts in detail. First is air natural cooling. In this method is used for dry type transformer. The air is surrounded vicinity of the transformer is used for cooling. This method is suitable for transformer up to range is 25 kVA, 5 kVA to 25 kVA. Here are the practical view of AN cooling system. Now the topic is air blast or air forced cooling system. This cooling method is suitable for dry type transformer slightly higher rating. The air is forced upon the tank surface to increase the rate of heat dissipation. The fans are turned on automatically to facilitate the forced air cooling whenever the winding temperature rises beyond the permissible limit. Here is also used the range of 25 kV. Here are some disadvantages of air forced cooling system. In this process, the increase the insulation strength is not obtained due to non-immersion in oil. And second disadvantage is a regular maintenance is must for this kind of transformer. Regular maintenance is needed. Now, the topic is oil natural cooling (ON) cooling system. In this type of cooling is used for oil-filled transformer up to the range of 30 MVA. As the oil in the tank gets heated due to the heated up core and winding, it flows upward and oil comes down as per the principle of conversion. The heat is transferred from various parts of the transformer on the oil and heat is used to cool by natural air. It is possible to increase the cooling area by provided the cooling tubes. The ONAN cooling system are shown in next slide. Here, here are the figures of the operation of natural cooling system. This is the practical view of ON cooling system. First figure and second figure both are practical view of ON cooling. Now the topic is oil natural air forced cooling. In this method, the transfer of the heat from various parts of the transformer take place naturally as explained for the ONAN type cooling. However, the hot oil is now cooled by names of the fan mounted near the transformer are shown in next slide. The forced air from the fans is directed to the cooling tubes, increase the tube rating. The thermoheat is used to automatically sense the temperature of the oil and winding and turns the fans on increase the above permissible. Here are the practical view of the ONAF cooling system. Now the topic is oil natural water forced cooling. In this type of cooling, the core and winding immersed in the insulating oil and cooling is improved by circulation of water through the copper cooling coils mounted above the transformer core but below the oil surface. The heated water is cooled in a sprayer round to cooling tower. This method will be cheaper while the natural water heat is already available. Next one is oil forced air natural cooling OFAN cooling. In this method, oil is circulated through the transformer with the help of pump and cooled in the heat exchanger by natural circulation of air. This method provides the very useful to cool have to be removed from the transformer. This method is not very common. Now the next topic is oil forced air forced cooling. This type of cooling prefers the transformer rating above 60 MVA. This type of cooling is used in shown in the previous slide figure. The separate cooler is mounted away from the transformer tank are shown in the next slide figure. This cooling is connected to the transformer with pipe and button on top. The oil is circulated from the transformer to the cooler with the help of oil pump. This oil is then subjected to the forced air cooling with the help of fan insulated inside the cooler. The OFAF type cooling is used for the big transformer used in the substation and power station. Here are the operation of OFAF cooling system. It is clear way to circulate the operation of OFAF. Here is the practical view of OFAF cooling of the transformer. Now, the next topic is oil forced water forced cooling system. In the oil forced water forced cooling system that they are used in the large transformer, this type of cooling needs the heat exchanger. Inside the heat exchanger, the heat from oil is transferred to the cooling water. The cooling water is taken away and cooled the separate cooler. The oil is forced and circulated through the heat exchanger by using pump. This type of cooling is used for transformer having a rating of few MVA, generally using generator transformer. Now we discuss the main application of the transformer cooling. Main application of the cooling is divided in various parts. First is air natural cooling is used for smaller output transformer having rating is generally 5 to 10 or 25 kVA. The air blast cooling is used to drive type transformer. In this rating, the voltage rating should be not exceed 25 kV. The third topic is oil forced. The oil forced air forced cooling is used to power transformer of a rating 30 MVA and more higher